Hey there, data wranglers. Ready to deep dive into some serious MySQL data dilution today?
We'll be exploring the nuances of different deletion methods.
So we're talking about keeping our databases squeaky clean and running smoothly,
Precisely.
all while making sure we don't accidentally hit a delete on something critical.
Think surgical precision over accidentally emptying the recycle bin. Trust me, it's a lot more interesting than just hitting the delete key.
Okay, I like that analogy. Now, we've got some great source material lined up for this deep dive. Code examples, comparison tables, even some error handling tips to keep those databases happy. But before we get into the nitty-gritty, let's set the stage a little bit. Why is delete such a big deal in the database world?
Well, imagine you're working with a massive customer database. Over time, that data can get outdated, inaccurate, even redundant. This clutter not only eats up valuable storage space, but also makes it harder to extract meaningful insights. That's where delete comes in.
Okay, so it's about maintaining data hygiene, kind of like weeding a garden to help the valuable plants thrive.
Right.
But I imagine there's more to it than just freeing up space, right?
Absolutely. Let's say you've got a table with sensitive customer information and there's been a data breach. Delete can be crucial for quickly removing that compromised data and minimizing potential damage.
Wow.
It's also essential for complying with data privacy regulations.
Wow. So delete isn't just about tidying up. It can be a critical line of defense for data security and compliance. That's pretty powerful.
It is. Now let's talk about how it works. At its core, the delete query with a where clause is the workhorse of data removal. Think of the where clause like a set of filters, allowing you to target and remove specific data while leaving the rest untouched.
So if we had a table called students and wanted to remove only the entries for students in class 4, we'd use a where clause to specify that, right?
Exactly. Our source material gives the example, delete from student where class 4. This query would remove only the students in class 4 and leave all other student records intact.
That targeted approach seems much safer than just wiping the entire table clean. But how do we make sure the delete command worked as intended? How do we know we deleted the right data?
That's where the connection affected rows function comes in handy.
Oh.
This nifty little function tells you exactly how many rows were deleted by the last query. So no more guessing games. You have concrete confirmation of the delete operation's impact.
So that's reassuring. So we've covered the basics of delete and how the where clause acts as a safety net. But I've heard whispers about something called bound parameters that take data security to the next level.
You heard right. Bound parameters are essential for preventing a common yet dangerous vulnerability known as SQL injection.
Okay, before we go any further, can you break down SQL injection for me? It sounds a bit intimidating.
Imagine someone tries to sneak malicious code into your database through a form field on your website. If your queries aren't properly protected, this malicious code could get executed, potentially giving the attacker control over your data.
Yikes. So how do bound parameters help prevent this? It sounds like we need to reinforce our defenses.
Think of bound parameters like designated entry points for your data. They essentially tell the database to treat the input as data, not as executable code, no matter what kind of sneaky characters someone tries to slip in.
Ah, so it's like having a security guard at the door, checking IDs and making sure only the right kind of data gets in. That makes sense.
Exactly. It's a way to sanitize your inputs and make sure your database only sees what it's supposed to see. Clean, harmless data.
So bound parameters are like adding an extra layer of security to our delete queries, making sure nothing fishy slips through the cracks. Our sources mention that we can implement these bound parameters using either object-oriented or procedural styles in PHP. Is one approach better than the other?
It really comes down to personal preference and the coding style you're most comfortable with. Both achieve the same goal of enhancing security. Think of it like choosing between a manual and an automatic transmission.
Okay.
Both get you where you need to go, but the experience is slightly different.
I like that analogy. So it's about finding the approach that feels most natural to your coding style. Now let's shift gears a bit and talk about situations where we need to delete data as part of a larger operation.
That's transactions come in, right?
Exactly. Imagine you're transferring money between bank accounts. You need to deduct the amount from one account and add it to another. A transaction ensures that if either of those operations fails, the entire process is reversed, preventing any discrepancies in the account balances. It's like having a safety net for your database operations, making sure everything happens as planned or not at all. Our source material walks us through a PHP code example where a delete operation is nested within a try-catch block to manage transactions. Can you break that down for us?
Absolutely. You'll see three key components: connection begin transaction, connection commit, and connection rollback.
Okay.
The code starts a transaction, then attempts to perform the delete operation. If everything goes smoothly, connection commit makes the changes permanent. However, if an error occurs, let's say the connection drops, to connection rollback gracefully reverses the delete, ensuring your data remains consistent.
That's incredible. It's like having an undo button for your database changes, preventing any catastrophic mistakes. Speaking of preventing mistakes, our sources also touch on error handling, which is crucial for any data operation, especially when delete is involved.
You're right, no one's perfect, and even with the best intentions, errors can happen. That's why it's essential to have robust error handling mechanisms in place. Our source code showcases how to use connection error to provide user-friendly error messages.
So instead of just spitting out a cryptic error code that leaves you scratching your head, you get a message that actually makes sense, right?
Precisely. Imagine you're trying to delete a customer record, but the database throws an error because that customer has pending orders. Instead of a generic error message, you could display a more informative one, like cannot delete customer, pending orders exist. This helps pinpoint the issue and allows for quicker resolution.
That makes a world of difference, especially for users who might not be database experts. User-friendly error messages can save everyone a lot of time and frustration. Now let's move on to those times when we need to clear an entire table. We're talking about delete versus truncate. They both seem to achieve the same outcome, emptying a table. So what's the difference?
You're right. Both commands ultimately result in an empty table, but they go about it in different ways, each with its own set of advantages and disadvantages. Think of it like this. Delete is like meticulously going through a closet, removing each item one by one. Truncate, on the other hand, is like taking a sledgehammer to the whole thing.
Okay.
Much faster, but definitely less subtle.
Okay, it's a vivid analogy. So delete offers more control and precision, while truncate is the way to go when you need speed and aren't concerned about individual records. Our source material mentions a significant difference related to auto-increment values, which are often used for primary keys. Can you elaborate on that?
Certainly. When you use delete to remove rows from a table, the auto-increment counter, which generates unique IDs for each row, keeps ticking along.
Yeah.
Any new rows inserted afterward will pick up where the counter left off, even if there are gaps in the sequence due to the deleted rows.
So it's like keeping track of a numbered list. Even if you remove some items, the numbering continues sequentially.
Exactly. Truncate, however, resets the auto-increment counter back to its starting value.
Okay.
So if you were to insert new rows after truncating a table, the primary key values would start over from the beginning.
That's an important distinction to be aware of, especially if you have applications that rely on those sequentially generated IDs for things like referencing or linking data.
Absolutely. Choosing between delete and truncate depends on your specific needs and the context of your database operations. Our source material provides a handy comparison table that summarizes the key differences: speed, data logging, impact on auto-increment values, and so on. It's worth reviewing to make informed decisions about which command is best for a given scenario.
This comparison table is super helpful. It's like having a cheat sheet for making the right decision between delete and truncate. But before we wrap up our deep dive into the world of data deletion, our sources mention one final command: do drop. And from the sounds of it, this one's a bit more permanent.
Yeah, you could say that. If delete is like removing files from a folder and truncate is like emptying the entire folder, then drop is like taking that folder and incinerating it.
Okay.
Talking complete removal, not just the data, but the entire table structure. Gone. Poof.
Okay, that's definitely a command to use with extreme caution. Are there any situations where using ddrop would be the best course of action?
Absolutely. Let's say you have a temporary table you use to store intermediate results during a complex data analysis process. Once the analysis is complete, you no longer need that table, and ddrop would be the cleanest way to get rid of it, freeing up resources and avoiding clutter.
So it's like dismantling a stage set after a play.
Right.
You don't need it anymore, and it's taking up valuable space. But with great power comes great responsibility, right? Our sources stress that ddrop is irreversible.
Exactly. Once you drop a table, there's no going back, no safety net, no undos. It's gone for good. That's why it's crucial to double, even triple check your syntax and make absolutely sure you're targeting the correct table before hitting enter.
Got it. It's like the big red button marked do not press. Only in this case, it's do not drop unless you're 100% certain. This deep dive has been incredibly insightful. We've covered everything from basic delete queries to the nuances of transactions, the differences between delete and truncate, and even the table obliterating power of drop. I feel like I've leveled up my database skills today.
It's been a pleasure exploring these concepts with you.
The pleasure was all mine. But before we sign off, one last thought for our listeners to ponder. We've seen how powerful prepared statements and transactions can be, especially when dealing with sensitive data. How can you integrate these techniques into your workflow to streamline your database operations and ensure data integrity? Could this be the key to simplifying your data management tasks and avoiding those heart-stopping moments when you realize you might have accidentally deleted something critical? Until next time, happy coding, everyone!